Have you ever thought about the essence of the vacuum? Many think that it is the vacuum itself and that it fills most of the outer space. But is that really all? What do we not know about the vacuum yet? Hello, guys. Is there a possibility of the vacuum that occupies most of the universe become responsible for its end? Welcome to our channel. You will be able to understand all this by watching this video. Let's go. The complete emptiness, or something different. The vacuum is the basic component of the universe. For you to have a notion, the vacuum fills practically the entire solar system that we inhabit. For example, between Earth and the Moon, there is a distance of 384,400 kilometers. That is, a vacuum much larger than the size of Earth and the Moon together. We can say the same for most planets and satellites. The larger the size, the larger the vacuum will also be. The volume of the vacuum that exists between the stars is many times greater than the size of the stars themselves. This also applies to the distance between clusters of galaxies. And for large-scale galaxies, something similar also happens. But is this vacuum we know a real vacuum? The answer is no, definitely not. The vacuum existing between two astronomical objects is completely different from a complete emptiness, a nothingness. At least a small celestial object like a meteorite and solar wind particles exist in several places in the solar system. And in the space between the stars, there are several molecules of atoms of various elements, such as hydrogen. This can become a serious problem when there are spaceships that travel at a speed close to the light. If the collision occurs at this speed, even if it is an atom or cosmic dust, it can end up causing significant damage to the ship. Thus, it will be necessary to create some protection field, such as a deflector shield or something similar to that. As you can see, what we call vacuum in space is actually not a complete emptiness. If we look from the point of view of quantum physics, emptiness has a certain amount of energy. In fact, the vacuum is full of quantum field. A feature of this quantum field is the fluctuation and spontaneous generation of antiparticle particles, such as electrons and positrons. Usually these particles fade in the blink of an eye. However, the endless generation of these pairs is what contributes to the generation of vacuum energy. For now, we do not know the exact value of this vacuum energy, but it is supposed to be a constant for the entire universe. In addition, if the vacuum energy is uniform and does not depend on volume, the vacuum must generate a certain gravitational field. Who knows, it may not be the enigmatic dark energy responsible for the accelerated expansion of the universe, immune to any resistance. There are scientists who believe that we can use the vacuum energy in our favor. If it is really possible to use the vacuum energy present in the universe, we would be completely independent of non-renewable resources, and we would no longer need to depend on solar and wind power plants either. Either way, it's clear that this is a problem for a distant future, and we don't even know if that's even possible. The vacuum, only in space? When we talk about vacuum, many must imagine space or some machine made by us here on Earth. However, the vacuum is actually present in several areas of our daily lives. In fact, we are also made of vacuum. Let's stop to think. Everything around us is made up of atoms. There is a great distance between the atomic nucleus and the electron, and if it is between different atoms, this distance is even greater. In other words, when we touch an object, we are not reeling in the atom itself, but in the field of force that exists between the atoms. The same can be said in relation to us. After all our organs and tissues are made up of atoms, and as there is a considerable distance between the atoms, the connection is made by the field of force. Thus, we can say that the vacuum is the deepest essence of our universe. Everything that exists in this world is empty, and even objects are made up of vacuum. The force responsible for the expansion of the universe, even if apparently imperceptible, ends up influencing us, and it also exists within us. This way of thinking, which sees the continuity existing between us and the universe, ends up acquiring a more mystical air, doesn't it? Anyway, let's get back to our subject today, the vacuum and its threat. The quantum field theory is defined by a formula, and according to it, there is a minimum value for the energy of the vacuum. As you know, with vacuum we mean the quantum field present in the whole universe. There is a possibility that this energy of the vacuum of the universe is greater than the limit established by us. What this means is that in some corner of this universe, a scary change can happen at any time. That is, this false vacuum present in the universe can turn into the true vacuum of zero energy. Let's represent this visually. Imagine a leaning wall leaning on the floor. There are small steps on this wall. If we put a ball on the wall and push it, it will be able to remain for a long time on the step. This is the state of false vacuum. However, this step is not the lowest place for the ball. The lowest place for it would be the floor. If we push the ball from the step, it will fall to the floor. That is, the energy will be in the state closest possible to zero. This is what happens when the true vacuum is generated somewhere in this universe. Everything that is touched by the true vacuum will be transformed into the true vacuum. And nothing will be able to maintain its original appearance. It is impossible to stop the true vacuum. Everything that touches the bubble of the true vacuum will become part of it. This process will continue until the true vacuum swallows everything and alters everything we know. It is very likely that any matter or atom will be destroyed in the condition of true vacuum. This is due, as has already been explained, by the fact that most of the atom is formed by the vacuum, and this vacuum will also try to return to its true state. Thus, the universe will become an elementary homogeneous particle, floating through the vacuum, as if it were a soup. But for now, there is no need to worry about something like that. 13 billion years have passed since the universe emerged, and this has never happened. In addition, there is a limit to everything. What I mean by that is that there is also a limit to the speed of expansion of the bubble of the true vacuum. This limit is the speed at which the true vacuum expands, that is, the speed of light. Therefore, even if at this exact moment the true vacuum arises somewhere in the Great Wall of Sloan, it will only reach us tens of billions of years from now. When that time comes, even if the true vacuum does not happen, the sun and the earth that we know will no longer exist. Who knows, until then, our post-human descendants have not evolved to divine levels and thought of some way to circumvent this bubble situation. From this theory about the false true vacuum, we can come to another surprising conclusion. The true vacuum is always one, as it is defined as a state of zero energy. However, theoretically, we can have several measures that exceed zero. That is, the energy of the false vacuum can have several measures, and there is a possibility that it has different values according to the universe. We cannot ignore the possibility that the difference in the state of energy may end up altering the laws of physics of this universe. If this is true, the exploration of other universes will be a serious problem, as all the space probes that were sent will be destroyed. The multiverse is a concept that for a long time has been gaining interest from scientists to ordinary people. Despite the interest in this time increasing, scientists have not yet obtained any concrete evidence of the existence of other universes. But if this hypothesis that several false vacuums emerged during the Big Bang and that each of them has become a distinct universe is proven, at least we could use it as theoretical evidence. And our video today ends here. Thank you all for the audience. I hope you enjoyed this content. Subscribe to our channel and leave a like if you liked our video. And don't forget to share this video on your social networks. Also comment on the subjects that are interesting. Maybe we can go after them and make a video about it. Well guys, it's time to say goodbye. Once again, thank you all for following us so far. I'll see you in the next video here on the Wikivedia Plus channel. A big hug, and see you there.